Okay, so we went over inverse functions and domain and range of the inverse functions and the regular functions, how they correlate to each other. But now we're going to go ahead and look at finding derivatives of inverse functions. So we have a question here, and it says, let f of x equal x cubed minus 3x squared minus 1. And it says for when x is greater than or equal to 2, find the value of the derivative of the inverse with respect to x. That's how we read these, with respect to x, at the point x is equal to negative 1, which is also equal to f of 3, our function of 3. So basically we're wanting to just find the value of the derivative of the inverse, right? Now, how we're going to go about this, there's actually a pretty easy process to go about it. We want to deal with first, we want to take our function here, and we're basically just going to take the derivative of it. Okay? Now, let's go ahead and start that. So, it was, go back to it, function of, okay. Our function of x is equal to x cubed minus 3x squared minus 1, right? And it says x is greater than or equal to 2. We're going to take the derivative first. So if we do that, we get df over dx, and that is equal to, so the power rule, right? Bring down a 3 and then subtract 1 from the power. We're going to get 3x squared, and then we have the second part, so this 2 will come down, be multiplied by the negative 3, and then we're going to subtract 1 from the power. So we end up having a negative 6x, and then derivative of a constant, that'll just go away. So we end up having nothing for that. Now, and since it says we want the derivative of the inverse, and it says at the point x is equal to negative 1, which is equal to f of 3, all we have to do is, since we know, we would want to plug in this to find it, but it says it's equal to a function of 3, which we have to have our x greater than 2, so 3 is greater than 2. Or have to be equal to or greater than 2, but this is our 3 is. So all we have to do, I like to do it this way. I like to just plug it in right there, because it's just easier when you plug it in. You'll see what I'm saying in a little bit. But so our df dx, and then basically we're just going to put our x is equal to our function of 3. So that just means we're going to plug in 3 into our x's. Okay. So when I do that, I'm going to get 3 times 3 squared minus 6 times 3. When I get that, this is going to be 3 times 9, right? And then this will become 6 times 3 is 18, so minus 18. You're going to get 27 minus 18, which will give you 9. So we know what that is now. Now there's a rule for the inverses. Basically, since we know the inverse, we're basically just going to take that value and we're just flipping it. So we have 1 over that. So if we wanted the inverse, the derivative of the inverse, all you would do is just take that value that we just got and basically just put 1 over that value. Okay? So, and we could write it like this. It would just be 1 over that value. Okay, 1 over df over dx, and then when our x is basically equal to 3, right? So when we found that it's 9, right? When we plugged in a 3, we found it was 9. So all we do is just we put 1 over 9. And that's it. That's all there is to these, really. You're just plugging in, you're taking the derivative, you're kind of just flipping it, you're putting 1 over that value, and then you just plug in. Okay, that's pretty much derivative of inverse function. So sometimes you might see a little more complicated, but just remember that, it's just 1 over that derivative of the original function, and then the value that you're going to plug in. So remember, inverse is when you switch the x with the y. So that's pretty much it with those. Alright, thanks.